All of the problems from these videos can be downloaded from accountingworkbook.com. Go to the website, click the PDF link, and you can download a copy of the workbook for yourself. Also on the website, you'll find all of my accounting videos, not just the ones I upload to YouTube. In fact, on the website, there are over 100 extra videos that I haven't uploaded to YouTube. So I do hope you'll check out accountingworkbook.com. Okay, let's get started with the problem. Let's take a look at problem 6.1a. So graphing cost behavior. We're going to have to draw graphs of various cost behaviors. It says for each of the following costs, prepare a rough graph. Why did I say rough graph? Because I can't draw a fancy, beautiful graph. So I'm just going to draw a rough graph that illustrates the cost behavior. The y-axis will be cost. The x-axis is activity. And that's always the way. And what do I mean when I say y and x-axes? Well, let's see here. If we look at a graph that looks like this, already my x is a little bit tilted there. This is the y and this is the x. And so on all of our graphs, y is going to represent cost, x is going to represent activity. You thought I was kidding when I said it's going to be rough. It's going to be rough. I'm just going to scroll a bunch of space so I have room to make lots more graphs. So let's look at A and see if we can see what that looks like on a graph. It says cost of a cell phone plan. The plan charges a flat rate of $20 per month for unlimited calling and text messaging plus 10 cents per megabyte. So if you use lots of gigabytes, that's going to be an expensive plan. But if you use very little data, that's probably a cheap plan. So what does this look like? Well, the first question I like to ask myself is where does the line start? And we draw these things from left to right. So let's just say I have a zero activity, right? I have zero. I get the phone, I get the plan, but I use zero data. Well, my phone still costs me $20. So the line isn't going to start here at zero. It's going to start somewhere up the line at, let's just arbitrarily pick this point, $20. Now, is it going to be a flat line? Is it going to be a fixed cost like this? No. The more I use it, the more megabytes I use, the more it's going to cost. So it's going to go up like this. So like I said, I'm not going to chart and say, okay, this is 10 cents and this is 20 or 10 megabytes and 20 megabytes. No. We're just drawing rough drawings. And that's roughly what this cost is going to look like. So it's going to be like a mixed cost, right? Fixed, it's got a fixed cost element. There's $20 of it that's fixed. And then after that, it's a variable cost based on usage. Letter B. Cost of plastic used in manufacturing small garbage bins. Each bin takes 600 grams of plastic. The activity is number of bins manufactured. Okay, so that was A. B. Let's see if I can draw a better. Yeah, I think that's a better thing. So cost, and then I've got activity. I don't think I'm going to write cost and activity every time. So cost of plastic used in making these little garbage cans. Okay, if I make 0 garbage cans, what is my plastics cost? My plastic cost is 0. So this is going to start from the origin. This is going to start from the bottom left corner of our L there. If I make 1 garbage can, it uses 600 grams of plastic, whatever plastic costs. So let's just say 600 grams cost me $1. 1 garbage can cost me $1. 2 garbage cans, what will that cost me? $2. 3 garbage cans, what will that cost me? $3 if 600 grams of plastic cost me $1. So what's this going to do then? It's just going to be a variable cost going up from the origin. Okay, let's look at C. Cost of rent on an automotive parts manufacturing factory. Okay, so we're renting a factory. We're Toyota, or we're the parts maker that supplies Toyota, and we have factory rent. Let's just say our rent is 10 grand a month. And of course, the activity is how many parts I make. So if my rent is 10 grand a month, if I make 0 parts, my rent is still 10K, whatever the number is, X. Like, it didn't give us a number, so I'm just making up 10K. So if I make 0 parts, my rent is 10K. If I make 1,000 parts, what's my rent? Well, my landlord doesn't know what I'm making. They don't care. So it doesn't matter the activity level. If it's 1,000 parts, 10,000 parts, or 1,000,000 parts, my rent is my rent. It's not tied to production. Therefore, this is going to be a fixed cost. It's going to draw like a fixed cost. It's just going to be a straight horizontal line. Graphing costs is something that students do tend to struggle with. Okay, next. Cost of professors' salaries to teach introductory accounting. Cost is $5,000 per class section. Sections have a maximum size of 50 students. The university typically has between 120 and 220 students enrolled in the course. The activity level is the number of students. Okay, so let's graph this professor's salaries cost. And again, the activity level is the number of students. So if I have 0 students, $0. But if I have 1 student, I start to have costs because I'm going to put in a professor in the classroom, and the professor is going to cost me $5,000, right? Now, if I have 2 students, it still costs me $5,000 until I get up to 50 students. Then when I'm at student number 51, what does my cost do? Well, it jumps to $10,000 because I got to add another professor. And it goes to $10,000 from 50 to 100 students. Then from 100 to 150, cost me another $5,000, jumps to $15K. From 150 to 200, it jumps to $20K, and so on. So that's the way this cost moves. We would call this a step fixed cost because it's a fixed cost for a pretty large chunk of time, right? Like, if I know if my school will know, like our intro accounting class, there's 140 students. Every year it's like 130 some years, 150 some years, but it's right around 140. So they know we need 3 professors. So if 3 professors and the cost is $5,000 each, they know, okay, it's $15,000 for that relevant range. So it's a cost but if there's a big change, it'll step down. If there's a big decrease in students, it'll step down. If there's a big increase in enrollment, so they'll have to add another professor. So they call it a step fixed cost in that it behaves a lot like a fixed cost a lot of the time. Because if your school is always between, say, 100 and 150 students, you're always lying within there, like 110 to 140. You know what your cost is going to be. It's going to be $15,000. It doesn't vary within that. So we call that step fixed. I should have been clear when I was laying this out. This is fixed. This one's variable. And we call the top one mixed. Okay, let's move on to E. Wages cost for staff at a construction site. The employees are paid $15 an hour, but must be paid a minimum of 2 hours and in 2-hour increments. All right, so this one's a little bit interesting. So my cost and my activity. Well, if everybody has the day off and there's 0 hours, there's going to be 0 cost. So this is going to start at the origin. Now, if I bring somebody in for even a minute, I got to pay them for 2 hours. That's a pretty common rule, at least in Canada. You can't bring somebody in for like 15 minutes and send them home and then just pay them for 15 minutes. There's like minimum call-in time, and it's 2 hours, at least in British Columbia. It used to be 4. Maybe it's 4. In any event, if I call somebody in, I'm paying them $30. Like the second they get called in, right? I pay them for 2 hours, they get $15 an hour. So that's my first 2 hours is $30. Then I decide I want to keep them for another hour. Well, I got to keep them for 2 because I have to keep them in increments of 2. So it jumps up. What is going on with my pen? And so this ends up looking like a staircase. These are all supposed to be the same size of stairs, but it's not. And they call this one a step variable cost. And it really does simulate a variable cost. If you were running the company, you would just treat it as a variable cost. And you'd say, well, it's not variable. Well, just like our friends here at a university will treat their professor costs as largely fixed, we're going to treat our labor costs as largely variable, even though there's a fixed element to it here. Okay, F. Cost of a private jet rental. The cost is $500 per hour for the first 4 hours and $300 per hour thereafter. All right, this is the one that every student in my class messes up when I ask a similar version. Here's what they want to do. They want to say, oh, the cost is, so it's a private jet, it's $500 an hour. So again, cost and activity, which will be hours in the air for the jet. $500 for the first few hours, and then they go, okay, it's going to go down, and $300 after that. So that's what students want to draw, and that is dead wrong. Think of it this way. If I fly 0 hours, what do I pay? 0. So it's got to start at 0. If I fly 1 hour, what do I pay? I pay $500. So if I fly 2 hours, what do I pay? I pay $1,000, right? I pay $500 per hour. So if I fly 2 hours, it's $1,000. 3 hours is $1,500. So what happens at 4 hours? Well, I don't pay less. I pay less per hour. And what happens is the slope of my line decreases because I'm paying less per hour. So my 4th hour, so if it's hour 3 is like $1,500, my 4th hour is just $300 more. It's $1,800. So it's a little bit closer, right? And the slope just decreases. So that's what this one ends up looking like. So F is one of the more difficult ones. It's one that my students certainly struggle with. Cost of a private jet rental, the cost of $500 per hour for the first 4 hours. Sorry, I changed it at 3. But I hope you got the picture, right? So it really should have changed at 4. So it goes all the same up to 4, and then at 4, it gets a little bit lower. Okay, let's move on to G. Cost of a rental car. Cost is a flat rate of $50 per day for the first 50 kilometers, then 50 cents per kilometer driven. Then we get an additional charge of 50 cents per kilometer driven. Okay, so cost km. So the cost is, does it start at 0? No way. It starts at $50. And does it start going up right away? Nope. I drive 50 kilometers. Once I'm at 50 kilometers, then the cost starts ticking up. So it's going to be flat until we get to the 50 kilometer mark. Then the cost is going to start to increase. So there we have it. That's our graph for G. So I know these were a little bit rough, but I've seen this type of question a lot in textbooks. I actually see it a lot where you have to match a cost description to a cost diagram. I always find it's better if you can sort of mentally figure out the cost yourself and diagram it yourself and then just match it on your own. But this exercise is meant to be useful just for understanding how a cost behaves. All right, folks, that's it for 6-1A.